Hello, so let's solve today's Leetcode daily challenge. Okay. Also, before we start, I would just like quickly introduce the CP tracker, and like this is a website to track your progress on Leetcode. So yeah, I should be able to edit the question, or no? I'm not sure what's going on. Okay, so let's just start solving the question, and now it should appear on the... Oh, they have different numbers. That's weird. Okay. Yeah, we are given with some... Okay, n by n matrix, and okay, so we have some grid, and we need to find three distinct rhombus so that in descending order. Okay, so we have one rhombus, and then okay, so the numbers on the some diagonal that makes the side of the rhombus. So, but the problem is why the side of rhombus is like always one. Is there anything specific about that? Oh, okay, it can't be more than one. Like for this case, we are trying to find the biggest one. That's why. Okay, yeah, it makes sense. The side of the rhombus should be pretty... The side of the grid should be pretty small, so... just by looking at this statement, the first observation is that n and m is like pretty small number, so that... which basically gives that we can do some brute force approach, but at the same time, I feel like we have to do some pre-compute diagonally so that we can do like n to the power of 4 solution. So what I mean by that is okay, so the 40 loops, we need this like the peak point of the rhombus. That's the first important thing to have in a loop, so which is I and j, which takes n squared, and then the next important thing is we need to be really precise about the side length of the rhombus, which is like k, so it would just become n cubed, which is... Can we do n to the power of 4? Yeah, we can do that. So okay, so this would become n cubed, and so we don't really have to do any pre-computing because just by this we can do n to the power of 4. So no, can we? So then we iterate through the sides, which also takes n. So the time complexity would be n to the power of 4 with this base complexity of just n squared, which is just the initial grid size. There are, with just by increasing the by pre-computing diagonal sums, we can do n-cube solution. That's for sure, but let's just do n to the power of 4 solution, then we get from there. Okay, let's just take n and then m is this, and from here and then we would have something like okay, I and j is that peak point of the rhombus, and then we go through the side of the rhombus, which is k. Yeah, so now we store the sum. Okay, let's first compute. Okay, we have the 4 number 1, 2, 3, 4. Okay, this size starting from 0, right? Okay, let's start from this side. Let's give it 1, 2, 3, 4, something like that. So the initial number plus 1 plus 1, and this is the okay. Let's be a bit more clear about the 0 0. We have 0 1, then 1 0 and 1. So the first would be I1 minus 0. Yeah. No, what was that? I1 is we are going from here, so it's increasing. Then the new x and y is wait, instead of 4 we can do something like x and y. Okay, after that we are this diagonal is x is increasing and y is y is decreasing. We have to take k elements, so that's why I'm doing this. Otherwise just break. Right. Then we have the right side. The right side will be right side. Okay, this is right side and this is the left side. Okay, now we have to compute. Also we have the same structure and we have x is also increasing and the y is also increasing and count is also increasing. Okay, now this left side. Now the difference is the starting point is a bit different, so that's one thing. X is I plus k minus 1 and y is j plus k minus 1. Yeah, this is the one. Also doing the same thing here. Now the x is still increasing. Here we are just like keep going down, and the y is also increasing. Okay, now right side, the bottom right side. The starting point is also a bit different, which is, and the y is, and the count is 0. Now the x is increasing, but the y is decreasing. And now we subtract the 4 numbers, which is like we counted this like a 4 numbers in the like those points twice, so that's why we are gonna subtract them. We went k down and then k down as well. Okay, now it's done, and okay, now let's check. Run timer integer overflow. What? Like, why would I have integer overflow? That's very weird. Oh, I forgot. I gotta do this k time, right? But still, that shouldn't be a problem. Which is pretty strange. Okay, now let's think. We are getting it k time, which is the length of this hide, and sum is 0, which is initiated here, and the initial grid numbers are also pretty small, 10 to the power of 5, so that's weird. Create x, y, x plus x. Oh, okay, maybe that's why. There's been a small mistake, but still, would it cause that issue? Maybe. Okay, we are getting wrong answer. 20, then maybe we are not thinking about the one case, no. Okay, now let's check. Okay, that's why. Okay, maybe it's this one because yeah, I think this is the solution, because for one case we are only adding it 4 times instead of, so we gotta subtract this 3 times. Okay. If case 1, okay, maybe case is like a special case that I should handle all before this. actually distinct. Oh. So what can I do? Okay, it's definitely taking a lot longer than what I initially expected. Just because I wrote just a bunch of repeated code and then I forgetting what the answer should be. So these things I should have. Otherwise, it's a pretty snark question, and my solution is really bad because it's n to the power of 4 instead of n cube, which I can do n cube solution with just a bit of pre-computing diagonal sums, but I don't want to do this right at the moment, so that's why.